This is Mr. Gillum, and today we're going to be learning about percent of a number. And this is lesson 5, day 2, and it's in your instruction book on page 40. At Madison Middle School, 60% of the 800 students participate in music. How many students participate in music? We haven't really necessarily talked about this a ton, and I know I haven't recorded it in one of my videos yet, but something that we need to keep in mind is that one whole is 100%. We call that 100%. The word percent, and the word cent means per 100. And whenever we have a percent sign behind something, we can think of it as that number over 100. The percent abbreviation is just a representation of dividing by 100. Okay? So these things I want you to keep in mind as we're going through this, because I'm going to kind of be bumping back and forth between fractions and percents. The percent sign, again, is just a shortcut way to say I'm dividing by 100, or it's just a fraction over 100. Okay? 100 represents one whole. So the first little deal here says we can picture this using a bar model. And because I know that 100% represents a whole, meaning all of the students, what I can do is I can separate this. I can just make 10 divisions. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the reason there's 10 divisions is because 10% is a quick calculation. 10% of 50 is 5, 10% of 60 is 6, 10% of 70 is 7, 10% of 100 is 10, 10% of 120 is 12. And I said all those things, and I hope you're thinking about them and listening to what I was saying on the recording, because what you'll notice is, even like 120%, if I want to know what 10% of that is, I'm just moving the decimal one spot. And so it's an easy calculation, and so a lot of times percent diagrams are divided into 10% pieces. Okay, and so that's what they've done this time. There's 10 pieces. Each piece of this bar diagram or bar model represents 10%. So in this case, we have 800 students, and so I know 800 students. If I want to know what 10% of that is, I just need to move the decimal one spot, and I know that there are 80 students in each of those 10%. So 10 groups of 80, each of those 80 would represent 10% of the total of 800 students. If I added all these 80s up, I would have 800 total students. Okay? So I could say that 10% is 80. 20% would be 80 plus 80. So 10% would be 80. 20% would be 160. 30% would be 240. 40%, 320, and I hope you're seeing a little pattern here. 400 is 50%. That's exactly half. 480, 560, 640, 720, and then finally 800. So if I asked you what 30% of 800 is, you would know it's 240. If I asked you what 70% of 240 is, you would know it's 560. So finding 10% of a number can be really beneficial, finding other percents as well. We could also think of it like an expression, and an expression does not have an equal sign. That's going to be important as well. No equal sign. Okay, when there's an expression. And so if in this case it says 60% of the students, 800 students, participate in music, how many students participate in music? If we talked about an expression to represent 60% of the 800 students, we could write it at like this. 60% of 800, these are the key words, this is the key phrase. Percent really is abbreviation for dividing by 100. So we can really think of 60% as 60 over 100, or 60 pieces out of 100 pieces. The word of, that's important, that means multiply. And this may be the first time you've seen a little dot used as multiplication. We do that because later on we're going to have variables and x is a variable that's used often. It can be confusing if you have too many x's in your arithmetic. So we use a little dot for multiplication, and then of 800. So 800 obviously is just a number. We're just going to leave that the same way. Now, the word of means to multiply. That's going to be important. That's a keyword in this entire lesson, lesson 5. The word of generally refers to multiplication. So this would be how we could write an expression using only numbers and operations. 60 over 100 multiplied by 800. So looking back at the bar diagram, I think that 60% of 800 would be 480. I think that's the solution to this question. If I were going to multiply it, 60 over 100 multiplied by 800. There's a couple ways to do this. I'm going to show you both ways. And we're going to do this again here in a minute, so you'll see it twice. One way is just by multiplying straight across, and that's fine to do. We don't cross multiply, that's for proportions. When we multiply fractions, we multiply straight across. And I know tricks with zeros. I hope that you've been exposed to those as well. I know 6 times 8 is 48, and I see 1, 2, 3 zeros. So I'm going to put 3 zeros, 48,000. And on the bottom, I know 100 times 1 is 100. I also know little tricks on base 10 that have to do with division with zeros. So if I divide 48,000 by 100, I know that I have 480. And you can see from before, we thought that we should have 480 students as well. Another way to do it that I prefer, and I think that everyone should know this, but it does require the understanding of factors and multiplication facts, is I prefer everybody to do it this way. 60 over 100 multiplied by 800 divided by 1. The reason that some people try to stay away from this, I think, is because when we talk about cross reducing, it gets confused with cross multiplication. I know that 100 and 800 share a factor of 100. 100 goes into 100 once and into 800 8 times. And so now when I multiply, I still go straight across, but now I go straight to my answer of 480. 60 times 8 is 480. 1 times 1 is 1. 480 over 1 is still 480, or 480 divided by 1 is 480. Okay, so let's go through these little problems here. We solved this problem. Let's walk through it again with number 2 through whatever number we're going to go through. It says the bar model shows 800 students divided into 10 groups of 80. Each group of 80 represents 10%. Well, we've talked about this. In the bar model, how many groups of 80 make up 60%? What is the total number of students in these groups? So I kind of already labeled this on our former bar graph here, but here's 60%. We can count up the number of 80s that makes 1, 2, 3, 4, 5, 6 groups of 80. So if you think about 6 times 80, we know that would be 480. So it says, what is the total number of students in each group? Each group has 80 students, and there are 6 groups. That makes 480 total students. So 60% of 800 students would be 480, just like we had talked about before. The expression from the previous page is shown below. Fill in the blanks to show how to multiply. So we've done this already too, but I'll show you the way the book kind of explains it. Again, they just know multiplication of fractions. You just multiply straight across. So they're going to multiply 60 times 800 and 100 times 1 straight across to get 48,000 over 100, just like we did before. But they also know to reduce the fraction, and they know the little zeros trick just like I do. They probably just said, oh, we just don't need those zeros. It's not necessary. It's an equivalent fraction to 480 over 1, so 480. I prefer, again, to kind of chop out this step here that has to do with reducing, because sometimes we don't know the reducing rules, and it's easier to reduce numbers that are smaller than that are bigger numbers. So I would do it this way. I'm going to show you again. I know I already showed you, but I'm going to show you again. I know that 100 goes into 100 once and 800 8 times. Now when I multiply, I get 480 over 1, or 480 divided by 1, which is 480. To find the percent of a number, here's what we need to do. Write the percent as a fraction and multiply the given number. So we could draw a huge diagram with 10% blocks every single time, but if we were looking for something like 18% or 12%, it's going to be hard to identify exactly how much that is. So we do need expressions to help us solve percent of a whole, is what I'm going to call it, percents of a whole. We're going to need to be able to change a percent into a fraction. Remember that percent means per 100, and then know how to multiply as well. The word of means multiply. Imagine that 55% of the 800 students participate in music instead of 60%. How can you use your idea of halves with the bar model to find 55% of 800? So I know that each of these is 80, and so I think I wrote this down earlier, 80, 160, 240. So you should have this on your paper already. There's 480. I know that 55% is exactly between 50% and 60%. So I need the number that's exactly between 400 and 480. Since there's a span of 80 numbers there, I know that 40 above 400 and 40 less than 480 will be right in the middle. So I know that 440 will be 55% of 800. Because I know that, like I said, because 55% is halfway between 50 and 60%. And 400 would be 50%, 480 would be 60%, halfway between those is 440. This example says that Charlie wants a new pair of shoes that cost $40. His mom pays 75% of the cost and Charlie pays 25%. How much do they each pay? Okay, so when I solve these types of problems, I speak the words out loud. I think of like the words I'm using. So his mom pays 75% of the cost, in this case, 40. So I'm going to think, okay, 75% of 40. That's what I'm thinking. And Charlie pays 25% of the cost, 25% of 40. So again, this is for Charlie, 25% of 40. So this is for Charlie. And the red would be for his mom. Mom's so nice. She buys shoes for you. Okay. When I decide to figure out what number is actually represented here by 75% of 40, I could make a big chart. 40 on the end with 10 divisions. And then each of them represent 10%. So 4, 8, 12, 16, 20, 24, 28, 32, 36, and 100% will be 40. And figure out, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be 10. Each of these represents a percent. I can make this big chart, and it looks like I'm already halfway there done with it anyway. So 100%, and so 75% would be halfway between 70 and 80, right there. So I would know it would be 30. That is a lot of work to do every single one of these problems, although I could also see the green one as well. 25% would be right here, halfway between 8 and 12, which would be 10. I prefer to do it with expressions. I know 75% can be written as 75 over 100. The word of means multiplication, and of 40. When I multiply, I prefer to think of that as a fraction as well. I can multiply straight across. I know that this will take a little longer. Looks like I will get 3,000. No, yeah. 3,000 over 100. And then, of course, my zeros make it 30, and that's what we thought the answer should be according to our chart here, 30. Now, I prefer you to just do this. Okay, well, I know 10 goes into that 4 times and into that 10 times. Cross that out for a 2, cross that out for a 5. 5 goes into 75, 15 times. 15 times 2 makes 30. It's really just your preference on what you prefer. I could do the same thing here. 25% could be represented as 25 over 100. Multiply by 40 or 40 over 1. 25 times 40 looks to me would make 1,000. 1,000 over 100 times 1 is 100. Get rid of my zeros. Looks like that would be 10, just like we decided. Okay. The last example, we'll go ahead and we'll do that one in class. Just remind me when we get there.